Now let us move ahead to learn the linear inequalities in two variables now. So the two variables we denote as x and y. Okay, so that means now we have to consider x and y coordinate axis, and in the xy plane we will be studying how to plot the inequalities and their solutions. Okay. Let's consider a very simple case, that is, suppose we say that x equal to 1. We know that that represents a line which is vertical parallel to y-axis, and that passes through the point 1, 0. Okay. So therefore that is line x equal to 1. Now this particular line will divide the entire plane into three parts, in the sense that the one which is on the right side of it, one on the left side, and the line itself, isn't it? So in this way the entire plane is divided into three regions due to any line present in that plane. Okay. Now if you consider the region that comes on the right side of this particular line, clearly if you consider any point on that side, the x coordinate of that point will be naturally greater than 1. Correct? So therefore that region represents the inequality x greater than 1 in the xy plane. Similarly, the region that comes to the left side of this particular line, if you consider any point in it, its x coordinate will be of course less than 1. Okay, so therefore that entire region indicates the inequality x less than 1, and the line itself indicates x equal to 1. So clearly we see that there are three parts into which the plane gets divided. Now instead of x equal to 1, suppose we consider y equal to 1. Okay, so in this case, as you can sense, we'll have to consider the line which is parallel to x-axis and passing through the point 0, 1. So that means y equal to 1 represents the line which is horizontal, that means it's parallel to x-axis. And if you consider the region which lies above this line, naturally it will be nothing but the region of y greater than 1, because all points in that region will have their y coordinates greater than 1, whereas the entire region that lies below that line will represent the inequality y less than 1. So in this way we can see that any line divides the xy plane into three regions. First is that line itself, which represents the equality, and the two remaining regions which represent the greater than and less than inequalities. Now here we considered very simple cases, that is where the line was either parallel to x-axis or y-axis. What if the line is making some angle other than these? That means what if the equation of the line contains both x and y terms? Okay, so let us practice how to show the inequalities related to the condition where x and y both terms are present. Okay, so let us solve one question based on that. Show the region denoted by 2x plus y less than or equal to 6. Okay, so here first of all, while plotting any inequality, first we have to consider the equality. That means we have to consider the line that is coming into the picture. So let us first consider the equality part, and we have 2x plus y equal to 6. Now from the concepts of straight line, we know that this represents a straight line, and we can find out how to plot that line. Okay, for that we use the intercept form. That means let us divide throughout by 6. So we will get x upon 3 plus y upon 6 equal to 1. So clearly 3 is the x-intercept, that means 3, 0 is the point where line cuts the x-axis, and 6 is the y-intercept, that means 0, 6 is the point where the line cuts y-axis. So let us plot the line first. So this is a crucial step. First we have to plot the line. Okay. Here we get 3, 0, and here we get 0, 6. Okay, the 2 points, and this is the line 2x plus y equal to 6. Now we have been asked to shade the region which represents the inequality 2x plus y less than or equal to 6, out of which the equality part clearly represents the line itself. Okay, so let us darken that. The line itself represents the equality. So here we darken the line. Now the remaining part is to show where does that less than region lie. Okay, so for that what we do is we do a simple test. That is, you see this line has divided the plane into two parts. Okay, one towards the origin side and the other away from the origin side. So we typically call this as origin side and non-origin side. So that, see here, using the words like, you know, above or below or to the left or right might be, you know, ambiguous in some cases whenever the line is, you know, slant line like this. Okay, so the better way to refer to the region are origin side and non-origin side. So we know that out of these two regions, one has to be the one which represents the less than case, and the other one will be naturally indicating the greater than case. So which is which? How to decide that? For that, we take any point in any region wherever we want. Okay, so for the simplicity, we take the origin because its coordinates are 0, 0, so they are simple for calculations. Okay, now if you substitute the coordinates of origin 0, 0 in the left hand side of the inequality, what do we get? We get 2 into 0 plus 0. That means that is equal to 0, isn't it? Now ask the question, is 0 less than 6? Does it satisfy the inequality? The answer is of course yes, it does. So that means the region on which the origin lies, that represents the region denoted by that particular inequality. So in other words, the origin side of this particular line that we are considering represents the inequality 2x plus y less than 6, and hence naturally we get the other side to represent 2x plus y greater than 6. It has to be 2x plus y greater than 6 only. Okay, so that means to show the required region, we will shade this particular region and along with the line that represents the required inequality. Alright, so in this way we can show any region which is denoted by the given inequalities. Now here you may wonder, what if the line itself passes through the origin, but still the method remains same? That is, it's not mandatory that you have to always take origin. You can take any point on any region. Okay, and we have to just check whether it satisfies the given inequality or not. If it does, then it represents that inequality. If it is not satisfying that, then obviously the other region represents the required inequality. Alright, let us practice one more question with a little more number of inequalities. So indicate the region satisfying all of the following inequalities. Alright, so here if you see, there are 4 inequalities given to us. First is x plus 2y less than or equal to 12. Second is x plus y less than or equal to 8. Third is x greater than or equal to 0, and last is y greater than or equal to 0. So once again, like we did earlier, first consider the equality that represents the line. Okay, now dividing by 12 throughout, we get x by 12 plus y upon 6 equal to 1. That means this particular line passes through 12, 0 and 0, 6. So we get these 2 points. So let us first draw them. Okay, so roughly I am drawing on scale. It's just rough. 12, 0 and 0, 6. Alright, then let's consider the second line. So here also we consider first the equality, that is x plus y equal to 8. So now since it's the same coefficient for x and y, we get x by 8 plus y by 8 equal to 1. So that means clearly 8, 0 and 0, 8 are the 2 points on the line. Okay, so let us show them. 0, 8 will be little above. I think it will come in between. So let me write the coordinates on the other side. This is 0, 6. See, 0, 8 will come somewhere above it. So this is 0, 8 and 8, 0. Of course, we have the origin also here. Now let us consider the first inequality, that is, we have to now shade the region of x plus 2y less than 12. Okay, equality we already know, that is the first line. Now for less than, once again let us consider the origin for convenience. If you put 0, 0 in the left hand side, it clearly satisfies the inequality because net we will get 0, which is less than or equal to 12. Okay, so therefore what we have to consider is the region which is on the origin side of that particular line. Okay, here let us not shade that region immediately, because all the regions when shaded they will get added up and cause confusion. So we will shade the final region at the end. Here we just now indicate that the region on origin side of the required line is to be considered. Now let's turn our attention to the second inequality, that is x plus y has to be less than or equal to 8. Out of that we consider the less than part now. Once again, here also we can consider the origin, and if you put in the inequality, that is 0 plus 0, which is 0 and which is surely less than 8. So that means origin lies on that side which indicates the inequality of less than. So for this line also, let us denote the required region by small arrows like this. Now let's consider the third one, that is x greater than or equal to 0. That means it has to be the region on the right side of y-axis, right? And lastly we have y greater than or equal to 0. That means the region lying above x-axis, and of course including x-axis also. So now look at all of these small arrows and decide mentally what is the region that satisfies all of these conditions simultaneously. Okay, so if you see that, then you will come to know that it is this particular region. You see, it satisfies all the conditions simultaneously, and we have to consider the edges also. So that is the graphical solution of the given inequalities, and since they are saying all of the following, so that means we have to only shade that region which satisfies all the 4 given inequalities.